triangles have three things. There are 3 points. Those points are called vertex or vertices, vertex singular, and in triangles we often just go with A, B, and C. In mathematics, we like to go around this way. This is what we consider a positive direction. We also call it counterclockwise. It doesn't matter. But once you throw out these labels, we are out of choices, because when we connect the vertices, we get 3 angles. Now, angles, we like to give it A, B, and C, but we're going to use lowercase Greek letters. The lowercase Greek letter for A is alpha. The lowercase Greek letter for B is called beta. Kind of fun to draw it. It's like the number 13, and then the 1 and the 3 somehow grew together. And there were issues with the letter C, so we jump to the letter G, which in Greek is gamma. You can think of that as the number 8 after some sort of an accident. The whole point of standard labeling is that without it, we would have to do a whole lot of explanations, because it does matter whether if you have a certain side and a certain angle, how are they related to each other. So standard labeling makes our life very, very easy by having this convention that the angle alpha is always at the vertex A. And the angle beta, surprise, surprise, is at point or vertex B, and angle gamma is at the point C. So no surprise there, right? So we talk about vertices and angles. But there are also 3 sides. Now, these are finite line segments, but when it comes to line segments or infinite straight lines, we like to use the lowercase Arabic letters. So for sides, we're going to use A, B, and C. That was a very easy assignment for alpha. It was very easy to naturally associate with point A. But if you look at point A, well, there are 2 sides coming out of A. Which one should we label as A? And the answer is neither. Let's call A the only one side that doesn't come out of point A. So it's actually opposite. There are 2 sides come out from point B, so side B should be the one that doesn't. So without this standard labeling, geometry problems would take a whole lot of explanations. But here we can say that A is 7 inches and beta is 32 angles, and we will know their relationship with each other, how they are arranged. So it just makes life easier. Now let me just say one thing about standard labeling. It's kind of smart. Imagine that we have a stick and another stick. Because we have sticks, that means that these sides are fixed. But we can open or close the angle as much as we want it to be. So then the handout has a more decent picture. Now look what happens. Standard labeling is smart because there is an organic connection between an angle and the side opposite of it. Here is the angle, here is the side opposite. The other 2 sides are fixed, right? Open up the angle a little bit, see what happens to the opposite side? It gets longer. And same with the red angle, it's really much bigger than the blue ones. So basically, if you increase an angle and you fix everything else, then the opposite side will also increase. And so the following facts, we will not prove them, but they are very useful and quite intuitive, is that if you have 3 sides, say A is 5 feet, B is 9 feet, and C is 8 feet, then we have no idea about the angles. But we know which is going to be the largest. The largest angle is opposite the longest side. So if we organize these, this is also very important. We usually assume a whole lot of things we shouldn't, like C is not always the longest side. So in this case, A is the shortest side, right, with 5. C is the middle one with 8 feet, and B is the longest one. And that means that between the 3 angles, alpha is going to be the smallest, gamma is going to be the middle one, and beta is going to be the largest. So the largest angle is always opposite the longest side, and vice versa, the longest side is always opposite the largest angle. Same with the shortest. The smallest angle is always opposite the shortest side, and the shortest side is always opposite the smallest angle. And there is one more very important consequence of this. What if 2 sides are equal? If 2 sides are equal, then the angles opposite them, which are the same letters, right, only in Greek, are also equal. And that's vice versa. If you have two angles equal to each other, that is sufficient for the two sides opposite them to be equal. It doesn't matter whether you find two equal angles in a triangle or two equal sides in a triangle. Just one is enough, and it will imply the other. This triangle is called isosceles. So this is an isosceles triangle. And if all three sides are equal, then automatically all three angles are equal. This one has a lot of names. If you want to say this is the triangle with equal angles, equiangular. Don't learn the pronunciation from me, please. Equilateral, I speculate, has to do with equal side length. And the one that I can spell and pronounce is just regular. So you're going to hear this one from me. You can use whichever you want. Thank you for watching.